In this video, we're going to cover sections 6.4 and 6.5. Section 6.4 defines something called a Bernoulli trial. A Bernoulli trial has the following characteristics. There are only two outcomes. Sometimes they're called success and failure. Basically, there are only two things that can happen. The probability of success is p, and the probability of failure is therefore going to be 1 minus p, because again, those are the only two things that can happen. And the trials are independent. So what happens on one trial doesn't affect what happens on a second trial. And an example of something that would be considered a Bernoulli trial is flipping a coin. There are only two outcomes, heads and tails. Probability of success is 0.5 and probability of failure 0.5. Those probabilities don't change. And the tosses are independent, so what happens on one toss doesn't affect the probability of what happens on the next toss. So we're going to calculate probabilities of situations where we have Bernoulli trials using something called the binomial model. And there are several other models described in section 6.5, but the only one that we're going to do in this class is the binomial model. So when we do the binomial model, we have some variables that we have to define. We have a number of trials, which is fixed or stated in the problem, and we have a probability, which as we said earlier is also fixed, and that will also be stated in the problem. P is the probability of success, Q is 1 minus P, and that's the probability of failure. Now, this formula for the probability here, you don't need to worry about this because we're going to calculate the probabilities for these using Minitab. So just cross that off. What you do need to worry about are the formulas below for mean and standard deviation. Luckily, these formulas are a lot simpler, but we are going to need to calculate these two values by hand. So mean, also known as expected value, is calculated by doing n times p, and standard deviation is calculated by taking the square root of n times p times q. So we're going to look at some examples here. It says, according to the Nielsen Company, approximately 30% of U.S. households have a DVR at the end of 2008. And we're looking at a simple random sample of 15 households. So the total number of trials, often the total number is going to be a sample size, the total number of whatever it is in your sample. That's going to be 15. So that's going to be my value for n. And my probability is 30%, or 0.3. And what I want to know is the probability that exactly 4 of the sampled households have a DVR. So I'm going to show you how to do this on Minitab. Now, when you're doing this on Minitab, you're not going to be entering anything into these cells like we were doing when we calculate things like the mean or make histograms, so don't worry about the cells down here. What I'm going to do is click on where it says probability. You can also get to this by clicking on graphs in the top toolbar and click on probability from there. And then I'm going to click on the top option, which is distribution plot. And I'm going to click on the last option here, which is display probability. It's going to open up this box. Now, it's automatically going to open it up into the normal distribution. We're going to talk about that a little bit later on, but I need to change that. If I click on the arrows here, I see lots of different choices for different distributions. Binomial is going to be at the top because they're in alphabetical order here. So I select binomial, and then it has a space for me to enter number of trials and event probability. And so number of trials was 15. Event probability is 0.3. Then what I'm going to do is click on a specified X value here. And then I need to choose right tail, left tail, or middle according to the context of the problem. We aren't going to do any in this section where you're going to be choosing equal tails. Now I choose right tail if it's a situation where I want to know about something greater than or equal to a specific number. Left tail would be less than or equal to a specific number. So thinking about the number line, numbers that are greater are on the right and numbers that are smaller are on the left. And we choose middle if it's either exactly one number or if it's between two numbers. And so this problem was asking me for probability of exactly 4 of the households having a DVR. So what I do if it's just one number that I'm interested in like that is I choose middle and I enter 4 in both boxes, x value 1 and x value 2. Then I click OK. And it's going to give me this graph. It looks like this. And the answer is going to be appearing over a red highlighted bar, or it might be a few red highlighted bars. So in this case, I can see the answer here is 0.218623. Now when you're doing the homework in MyStatLab, they're going to ask you to round to a specific number of decimal places, so make sure that you're paying attention to that. Some of the problems will say 3 decimal places and some of them will say 4 decimal places, so just be aware. So if I round to 4 decimal places here, that's going to be 0.2186. So I can write that in. So 21.8% is the probability that exactly 4 of the households will have a DVR. So I'm going to write down here I chose middle, x value 1 was 4, and x value 2 is 4. For number 2, it says to find the probability that fewer than 3 of the households have a DVR. So I have my same values for N and P that I had before, but this time it says fewer than 3. So when I'm thinking about this, what I need to do is work with the biggest or smallest whole number that is included. Fewer than 3 means that it can't be exactly 3. It has to be 2 or less. So since it's less, that means that I'm going to be doing a left tail, and my x value that I'm going to enter is going to be 2. So I'll show you that on Minitab. So I need to go to probability again, distribution plot again, click on display probability again. All of these I need to change again, enter these values again, and we have left tail. Click on a specified x value and enter my x value of 2. Click OK, and it's going to bring up a new graph. If I want to go back to one of my previous graphs, this navigator bar over here will keep them available so I can go back to see my previous answers. But for this one, the value that I get for the probability is 0.1268. So I'll write that down. So 12.7% chance fewer than 3 households will have a DVR out of 15. So 2 out of the 15 or 1 out of the 15 or none out of the 15 will have a DVR. Number 3 says to find the probability that at least 5 of the households have a DVR. So for this problem, it says at least 5, so that means 5 or more. So I'm going to use my same values for N and P. This is going to be a right tail, and I'm going to enter 5 for X. So it looks like my answer is 0.4845. And number 4 says to find the probability that the number of households that have a DVR is between 1 and 3 inclusive. So between two numbers means that I'm doing middle, and I would set my x1 value to be 1 and my x2 value to be 3. So those are the two numbers that I'm looking for in between. My n value and my p value are the same. And it looks like the answer here is 0.2921. So that's how you calculate the probabilities using Minitab. Now for questions 5 and 6, I'm not going to use Minitab. I'm going to use the formulas that we saw earlier. Question 5 says to find the expected number of households. And as we talked about earlier, expected number or expected value is another way of saying the mean. So we're going to use the formula for the mean, which is n times p. My value of n is 15, and my value of p is 0.3. And when I multiply those together, I get 4.5. So this is saying that if I have a sample of 15 households, I would expect on average that 4.5 of the households will have a DVR. Now obviously none of them will be 4.5 households since I can't have half of a household, but if I did the sample repeatedly, on average I would find it to be 4.5. And then question 6 is asking for the standard deviation. So that formula was square root of NPQ. And my value of n is 15. My value for p is 0.3. And my value for q is 1 minus 0.3, which is 0.7. So I just type that into a calculator and I get approximately 1.77.